Welcome to our mathematics class today. Guys, I hope you guys are all doing well. We started off yesterday by looking at area of part of the circle. And then under area of part of the circle, we kick off by understanding what we meant by area of a sector. We know that in a given circle, we have radius, and these have been well demonstrated in our class yesterday when two radii divide an enclosed circle. And when this is done, the two parts that has been divided is what we call the radii. The radii, of course, the radii is also separated by an arc of the circle, and we were able to calculate the sector of the circle and also to explain what is an arc of a circle. So in today's class, I would like us to move forward to now what we call the segment of a given circle. So when we have segment, for instance, we are looking at segment. This is segment. What is a segment? A segment is nothing but a part of the circle, and this part of the circle is being cut off by a chord. So when you cut this part off, you can see this side that is shaded. You see this side that is shaded. It is cut off. We cut this part off from the circle. This side that we cut off, we call it the minor segment, while the whole of all the remaining part of the circle is what we call the major segment. So we have the minor segment and then we have the major segment. Of course, these two length that is extended from the center here, this is what we call the radius of the circle. So this is the radius of the circle. As you can see, that is the radius of the circle, and then you can see it is connected from O, that is AOP, which is forming a chord. From this chord here, this is a chord. This line here, we call it chord. We call it chord. So with these explanations, you'll be able to calculate you'll be able to calculate a segment of a given circle. A segment of a given circle. Take for instance the question that you can see on your screen. You are to find the area of the segment AYB if radius of the circle is 21 centimeter, and then we have angle AOB to be 120 degrees Celsius. Pi, we know pi is 22/7, which is approximately 3.142. So look at that question and then tell me what you can do to solve them. The very first thing you need to pay attention here in this question, I purposely put the solutions so that you will be able to follow up as we try to illustrate that. You can see that R is already given in the question as 21 centimeter, and then we have angle AO. We have this angle here to be 120. That is angle AOB to be 120. We have the arc length, which is given as the arc, the area sector. So the equations that we need to calculate these, we know that the equation of the circle of the segment, to get the sector, we get the angle of the center first. So we have to get the angle, and when we get the angle, we will be able to find what we are supposed to do in this given question. So we have area segment, which is the area sector. The area segment, we are talking about the area of the circle, is going to be given by the area of this small chord area here, the segment of the circle that is being cut off by a chord that is being cut off here, this side, the area minus the area of the given angle, minus the area of the given angle, or the area of the small triangle. You can see this is a small triangle where you can see 120 degrees. it is forming a right angle triangle from the segment. So now you simply plug in these given values, and you will have 120, because we know theta divided by 360 multiplied by pi r over 2 will give us the area of that place. So the angle we are given is 120. Divide that angle by 360 multiplied by pi, and we know pi is given as 22/7. Now multiply this by the radius, which is 21, times 21, because it has to be r squared, and you will get 462 centimeters squared, or squared centimeter. So that is what you are supposed to do in order for you to calculate any area of a circle segment, when you are asked to calculate the segment of a given circle. This is an illustration. Let me give you another example that we are going to walk through step by step, and that will help you understand how you can calculate the segment of a given circle. Okay, we continue, guys. This is the question we have. I can see Purity from 2 North has joined the class. Purity, can you hear me? Okay, maybe she's having a network issue. You tell us when you finally succeeded to join the class properly. We are in the figure below. You are to calculate A, the distance ON, area of sector OXPY, and area of triangle OXY, D, area of minor sector, and finally we are to calculate the area of the major segment. So first of all, let us have our circle. Let me draw a circle here. Let's say this is our circle, and in this circle we want to find, we first of all divide this side. So this is now our minor segment. This side, this is the minor segment, and this is the major segment. Welcome back, Purity. So from here you can connect from here up to this point and join it up, join this up. So the distances that you can see there, this is our O. Of course, this place is represented in the form of right angle triangle, 90 from the center there. So you have that, and then this is 90 degrees. This is 90 degrees. This is N. We are so N. Can take a different color to show that. We can take a different color to show that N. So this is N. This is O, like you can see. And then this length, the segment here is 12 centimeter. 12 centimeter. And then we have our X. This is X. This is Y. And this is P. This is P. So we are told to calculate the distance ON. Option B, area of sector OXPY, and OXY, that is OXY, and then we find the area of this minor segment, and then we find the area of the bigger side, which is area of the major segment. Purity, can you hear me? I hope you are still in class. So this is the area of the major segment. I can see you. Unmute yourself and talk to us. So look at what you have on the board. Let's see how we can handle this question. I hope all of you have written that. So we can raise this up a bit. If I raise it up, we are able to calculate. The first one is the area of ON. We are supposed to find ON. And the thing we need to, ON is just this right angle triangle that you can see here. You can see this right angle triangle. You can see this one. So we want to calculate this area. So there is a small triangle here. There is a small triangle that we want to calculate, this triangle. So let's draw this triangle outside. If we draw that triangle, you will have something like this. This is that triangle. So this is OXN. This is OXN. OXN. That's what you have there. This is X. OXN. So if this length from X to Y is 12, it means that from X to N will be 6. This will be 6 centimeter, and this will also be 6. So what you have here is 6 centimeter. And then we have this as 10. This length from O to X is 10. So this is 10. Centimeter, 10 centimeter. So this is 10 centimeter. So now you go ahead using the Pythagoras theorem. We know that x squared, a squared plus b squared is equals to c squared. So what is our ON? Our ON in this case is going to be the square root of 10 squared. 10 squared minus 6 squared. So take the square root of this. And what you will get will be 10 squared minus 6 squared will give us 8 centimeter. The square root of this will be 8. So ON is equal to 8 centimeter. This is question A, the option A. So now, option B. B is asking us to calculate area of sector OXPY. OXPY. So B is OXPY. To get the sector, we need to get the angle of the center first in order for us to find the area of OXPY. So we know that by sine and cosine rule, opposite all over adjacent, because when you look at that angle, you will see it is opposite over adjacent. And we know that what is opposite over adjacent, it is simply the tan of that angle. So it is tan theta. Tan theta is going to be 6 over 8 now. It is 6 over 8. This is 6 over 8. 6 over 8. Because 8 is that angle ON. So is 6 over 8 opposite over adjacent. So 6 over 8 in that case, 6 over 8 in that case implies that what we are going to have will be 3 over 4. 3 by 4. So the tan inverse will give us that angle. Tan inverse of 3 over 4. Tan inverse of 3 over 4 is going to be what? Put in your calculator and tell me the answer. Of course, this is an acute angle. That is supposed to be 36.87 degrees. So the bigger angle now, the bigger angle, which is the angle OXY, is going to be, XOY is going to be 2 multiplied by 36, what we have here. So multiply these by 2 to get the bigger angle, so that the bigger angle will be 73.74 degrees. So now that you have the bigger angle, you can find the area of the sector OXPY. So area of that sector OXPY is therefore going to be, let me use red, is going to be 73, which is the angle of the bigger triangle, 73.74. Divide this by 360 degrees. 360 degrees, multiply by pi.